All right, so hopefully everyone can see my screen. Yeah, so I've been working on kind of a side project past 3 months, I think from mid-April or something, just testing out ideas for a new web app scanner because I had a bunch of ideas that I wanted to see if they actually worked. And this is kind of the culmination of that. So I'm just gonna hop right in. For those who aren't aware, I've been in R&D for DAS-related stuff. It's kind of my jam. Been doing it for 8 years, 8 or 9 years. Been 6 months at GitLab, so yay me. 20 years in InfoSec total. Been doing a lot of browser research over the years. So Chrome has been my kind of go-to for that. Did a lot of Firefox work in the past, but it's not really as good as Chrome. So kind of switched over to Chrome a couple of years ago. So gonna just go over the quick topics, what and why, some of the design demos, a roadmap, and next steps. So the what and why. So Browserker, again, as I stated, I started this in mid-April as kind of a side project. I wanted to see if I could build a scanner that did not use a proxy because proxies introduce a lot of complexity when it comes to correlating requests and responses from the browser and having to deal with certificates and all these things that you have to kind of deal with when you're using a proxy for doing your injection-based attacks. It allows for plugins to be written in Go or JavaScript. So JavaScript, I use a library called Goja, which allows you to basically create a VM inside of Go. There's a new one that I have to check out, but for now I'm using Goja. And the reason I did this is because it I wanted to make it easier for plugin writers to create new plugins. With the plugins themselves, you can get notifications for basically any type of browser event. You can register hooks into each of these types of events. So like if you have like local storage, if the service, if your web application stores data in local storage or session storage, you could actually be notified in your plugin of that. So you could say like, oh, is someone storing a password in there? Stuff like that. It allows you to inject JavaScript before or after a page loads. So sometimes you'll want to hook various things from a plugin. So you could do that before the page loads, or you could do it after the page loads to inspect or do some sort of analysis after the fact. And each plugin can, if they request it, can get full access to the browser so they can do all these fancy things that they want to do. The data storage layer, I built a custom graph database based off of BadgerDB, which is an amazing key value data store. The reason I chose obviously crawling is kind of a graph-based problem. So to store the data properly and be able to replay navigations as you're crawling through an application, it made sense to have some sort of graph-based database. And the crawler itself, so it works on newer JS frameworks such as Vue, React, and Angular. The reason it does that is because just the way that I've kind of developed the navigations and actions that I take within the browser. I do have plans to actually hook various framework-related functionality to say like, okay, if this is Vue.js and it's using a particular type of router, hook that, try to get all the list of navigations that I can get from that, and then just crawl it directly. But right now it's not in place, but so far my crawler has been working pretty well. So on to the why. So web app scanners these days, you really have to use a browser to drive coverage. Just parsing HTML and pulling out links just is not enough anymore. Just the way that if you look at an HTML page as it comes directly from the network, you're going to just see like basically hooks for the SPA or the SPA system to basically dynamically generate an entirely different looking page. So you can't just scan for links anymore. It just doesn't work. So Zap, while it was a pioneer in open source scanning, it's starting to show its age a little bit. It doesn't really consider a browser as being a first-class citizen. It's kind of like an add-on or extension that you can use to increase your coverage. But for the most part, it's kind of like an afterthought. Also, there's a lot of legacy UI code and architecture. So anytime they have to make changes, they have to make sure that their UI is updated. It's just, they have a lot of technical debt that's going to be a burden to make them really be able to move quickly forward. So my tool does not have any sort of UI. It's completely command line driven, particularly for that reason, because I don't want to deal with UI stuff. I don't really like proxies. I've had lots of issues in the past with them, but I do like browsers. So that's kind of why I wanted to test out these ideas. And I wanted to make sure that it was something kind of new that worked for what people are developing today, not so much the old legacy types of tools or excuse me, automated. So just like a simple config, if you think about Zap, it has this context file, which has these script files, which has these policy files, and it's just this huge, like kind of interconnected mess of different type of configs that you need. I just want a single config where you say, I want these types of form values. I want to allow these hosts. I want to disallow these hosts, and kind of go from there. And finally, I was really bored. So that was pretty much the entire reason I started writing this on the nights and weekends. Into the design. So Browserker is almost entirely based off of DevTools. If you're not familiar with DevTools, every time you open the DevTools in Chrome, you're able to inspect elements and event listeners and look at network traffic. All of that is exposed as a service that you can actually connect to over port, whatever port you specify. So you can tell Chrome to start up and say, hey, turn on the DevTools debugger, and then you connect into it. And then if you know the protocol, you can communicate over, it's using a WebSocket protocol. So what this allows Browserker to have is full access to the JavaScript debugger. So you can imagine all sorts of the cool instrumentation stuff you can do with doing instrumentation of a target page. Target page is JavaScript. You get full access to the page and DOM capabilities. So you can use XPath selectors, CSS selectors to search for particular elements and pull out the data from that. You get full access to the console messages, the local session storage, as I mentioned, and you can access most of the network layer. You can intercept requests and responses. And then recently they allowed you to modify them via the fetch API, not the fetch JavaScript method or object, but there's an actual domain called fetch that allows you to intercept and modify requests. You cannot intercept WebSockets directly yet. I have plans in place to hook that instead. So as you traverse through the application, it's taking snapshots of how the pages are changing. So I'd be able to intercept and say, okay, there's a WebSocket. When I click this button, this WebSocket message just appeared in the time that it took after I clicked that until the page settled. So I'd imagine using something like that to be able to do some sort of WebSocket analysis. So how I do this from Go is I have an API generator for DevTools called GCD. I wrote about 6 years ago, and I've been kind of keeping it up to date because they update the DevTools protocol JSON file quite often. Pretty much every time I go to look at my generator, they've updated it, changed some sort of feature or something. So Browserker completely uses this to instrument the browser pretty much at every step. Browserker also runs in headless, so it's Chrome headless, no crazy XVFB stuff you have to deal with. So it's great for CI/CD, but you can also just not run it in headless. So it's just your regular Chrome process that you can kind of interact with and watch and see how things are working. So it really makes it good for CI/CD because you don't have to worry about any of that messy stuff. Same with the proxy. You don't have to worry about certification interception issues, or you don't have to worry about new HTTP 2.0 or quick and speedy because it's all kind of within the browser itself. As I mentioned, the GraphDB is built for handling complex page flows. It's a graph, so you can basically traverse it as you want. Right now, it's pretty straightforward. It's just kind of linearly going through the graph to find new navigation attempts and stuff. But I can imagine there's going to be optimizations that are possible there for kind of short-circuiting different paths that you want to take. So when it comes to uniqueness, uniqueness is obviously a huge issue with a DAS tool because you need to determine what's new, and otherwise you are going to end up crawling the same thing over and over and over again. Unfortunately, these days with single-page apps, URLs are pretty much meaningless. You have your kind of URL fragment, which may update or may change, but there's cases where it's going to be adding new components to the page, and it's never going to touch the network, and you won't be able to see that or inject anything through a proxy-based attack tool because nothing is going over the network. So the way Browserker deals with this is something called just actions. So each type of action that you can take against a target application, there's kind of a set scheme for it. So like loading URLs, form fillings, almost everything within Browserker is hashed for uniqueness. So DOM elements, requests, navigations, reports, results, everything to try to make sure that you're not getting duplicate results over and over again. Each browser itself is an isolated process. So I have this concept of a leaser service where it starts up and it says, okay, I want 6 browsers. So it'll actually start 6 individual Chrome processes, and then the scanner engine can request it from that leaser and do its stuff. And when it requests it from the leaser, it actually, memory-wise, all the things that it needs to kind of interact with are isolated to that browser process. So for example, if I'm capturing network requests and responses, it's all contained within that browser's context. So I don't have any sort of leaking of like issues of requests coming in from different browsers. It's all completely isolated. And it makes managing memory a lot easier. So that's kind of why I want that. And also browsers crash like all the time. So you don't want to have all of it running within a single browser instance, but multiple tabs, because if one tab crashes, it could potentially take down the entire browser. So yeah, keeping them isolated is super key. The plugin system, I based it off kind of a set of configurations. So one thing a lot of plugins kind of have to deal with is, or a lot of times they don't want to see every single request, or they don't want to see every type of page. They only want to run their particular checks in certain circumstances. So for example, maybe they only want to run once for the entire domain or the target. They only want to run once per unique directory. So if you think about like server headers, if you ran your server header check against every single page, you're going to get a lot of duplicates. So I created this kind of configuration to minimize that and allow plugin authors to determine only when they want to run. And it has your standard types of passive plugins, which kind of just passively intercept traffic or events from the browser, and then your active ones, which are actually doing attacks against the target. And again, these plugins have full access to the browser, so anything you can dream up of running in the browser, you could probably do with a plugin. And again, it registers for what it cares about. So if you only want storage events, great. You just say, I want to listen for storage events, and you'll only get those, and then you can do your reporting from there. Unique vulnerability IDs, this is something I'm definitely going to enforce, because we've obviously seen issues with that with our current DAST offering, just to make it easier for correlating and reporting information and uniqueness amongst issues that are found. And as I mentioned, the JS plugin stuff, which will allow you to write customized checks without recompiling the entire tool. It's what I consider a clean architecture in the sense that all domain types and interfaces are defined in a single package. And I'll kind of walk through this as the demo runs. But basically, the primary package kind of main package is not allowed to import anything from the rest of the code. So it's isolated as much as possible. It allows decoupling of services and makes mocking super straightforward and safe. And another kind of key point is tooling. When you're dealing with crawling, there's just so many things that can go wrong, and not having good debugging tools to assist you into determining what exactly the crawler is doing, why it wasn't able to find an injection point, or why it wasn't able to do a certain action. I built a lot of tooling around that just to minimize the amount of time I have, because you don't want to sit there, if a scan's running and after 40 minutes, it doesn't find this one vulnerability. You don't want to sit there and have to rerun 40-minute scan every single time. So I allow you to replay specific navigations. So you can say, okay, it got to this point, and here's this ID for it, replay until that point, and then I can capture what I need to debug and find the issue and hopefully fix it. So, and the profiling stuff, I'm going to demonstrate that. If people aren't aware of how you can use the profiling stuff built into Go, it's super important for finding like Go routine leaks and channel issues and synchronization and just allocation issues in general. So I'll show that later. Crawling itself, so it's got 3 kind of things I consider its currency. It's the navigation path, so that's actually going from one, if like clicking on a link and then filling a form and then sending some attack or whatever, that is considered a navigation path. And each one of those steps is made up of a navigation. And then from the navigation, it's made up of an action. So an action could be clicking on something, or it could be a kind of more complex action, such as filling a form, where it's doing multiple actions all at once. And yeah, as I mentioned, the navigations contain one unique action to take, but again, there could be multiple steps. And then the paths are just the sequence of those navigations. So when it's doing its crawling, once it gets to the final step of its navigation path, then it starts turning on instrumentation to determine what is changed. So it'll say, after I click this before I click this, take a snapshot of the entire page, what exists, what elements are there, and then click it and then see what happened. So did the page transition to a new one? Capture that. It did 3 new elements show up that are clickable, capture that, and then create a new set of navigations based off of that. And here's kind of the workflow for that. So the engine takes in a config, and the config says, hey, I want 10 browsers. And the leaser starts up 10 browsers. And then usually the config will have some sort of URL that you want to attack. So it adds that to the crawl graph, say, here, action load URL for this target URL. And then there's this kind of cycle or this process that says, okay, give me all the new navigations that you have. And it does that by querying the crawl graph saying, give me all navigations that have the state of not visited or unvisited. And then the crawl graph will return that. And then it can request a browser for each one of those navigation paths. So one browser gets one navigation path, and then it executes all those navigations. And then the browser executes the action, it gets the results, returns the new navigations to the engine. The engine can do its kind of differential, like what is new, what isn't new. And then it puts it back into the crawl graph as an unvisited state, and then the cycle, and then it returns the browser to destroy all the context related stuff, and then it kind of restarts over and over again until there's no more unvisited. Is there any questions so far?
I mean, I have a heap, but I can wait to the end.
Okay. Crawling is hard. It is very hard. What I came up with is, as I kind of already mentioned, is that there's kind of a before action is executed, you kind of snapshot the browser, and then you execute the action, and then you just kind of see what's new. All of these things are kind of hashed and compared to make sure that there's no kind of duplication of types of steps. Like, for example, new navigations will be hashed to make sure that they don't actually already exist in the crawl graph, or elements will be hashed to see if we've already visited that element before, and it's all stored within either the browser's kind of isolated system or within the crawl graph itself. And you can see here, this is like some of the stuff that I'll capture, like messages or HTTP requests and responses. And then the DOM, obviously you capture that, URLs, cookies, storage events, console events. And there's some other stuff I just haven't added yet, but it's pretty straightforward to add it here. So for finding elements, it goes through a number of different steps. It looks for forms first because they're kind of the most important. It collects all of the child inputs and fields and labels and kind of creates this kind of little snapshot of what a form is. It then iterates over any buttons that exist that might be floating off somewhere. All the A tags and their links, the interactables. So this is basically what, if you have any sort of event listener bound to an element, whether it's statically bound, so you have like element dot on click equals some function, or get element by ID and then add event listener, click equals, or then function. So the DevTools protocol, if you give it they call them node IDs. If you give it a node ID, it'll say, here's all the event listeners that are bound for that particular element. And then you can actually pull out the line number and column number from JavaScript where that element event listener is actually assigned to it. So, and then it looks for any text nodes and its parents and images. So the image one is kind of interesting because when I was crawling WebGoat, I was really getting frustrated because WebGoat is not easy to crawl. And I'm like, it's just a stupid element. It's right, or it's just a stupid link with an image. Just click the link. Why isn't it doing that? I'm like, why don't I just make it click all the links or click all the images? And I did that, and I got amazing coverage afterwards. So it really helped out. The kind of final step of this, once it finds all these elements, is to check if it's hidden. And the way that I do that is I actually try to, given the elements, I say, can you give me the center of that element? So can you find me the DOM box of that element? And if the DevTools protocol says it's not visible or I can't find it, then I say this is not visible yet, so it's technically hidden. And then from there, I can basically filter those out. So if you think about when you're crawling something, if something's hidden and you click it and then it becomes unhidden, that's clearly that click action caused that element to become unhidden, which means it's a new navigation built from that one. So Form filling, there's two types of forms. There's the form tag forms, which are super easy. You just find the form tags, iterate over the children, and then I pass it to a custom form filler, which I'll explain in a second. And then there's floating forms, and floating forms are not easy. When crawling JuShop does not use any form. It uses divs with form attributes. So what I ended up coming up with is this kind of method of using XPath selectors to say, okay, if it has an attribute that contains the text form, go back and find all the descendants of that and pull out the inputs and pull out the buttons and the select elements. So obviously, once you do that against an entire page, it's going to, if there's multiple forms, it's going to give you a lot of results. So the way that I kind of split it up is to say, okay, if it comes back with 3 buttons, take all of the input elements and basically mirror them for each one and consider it to be 3 different unique forms, and then it can go through. And the benefit of that is even if you submit a form that the inputs don't match that button, like maybe it's a clear button or something, you're not going to get any new results. So your navigation at that point will be terminated. But if it ends up working, once you hit that submit button and you find new navigations or transitions to a new page, you all of a sudden have a new navigation path, and the crawler can continue down that path and neglect those other ones that didn't work. So that turned out to work really well. Form filling itself is pretty smart. It's context aware. It's user configurable for form data. So I have a lot of different stuff in there, whether it's like travel information or credit card information, address information, etc. What it does is it basically, all those inputs, it kind of iterates over them and says, okay, is this a date? Yes, spit out a date that's like 1 day from now, maybe at 9:30. Is it a number? Spit out a number. If there's any sort of constraints, like if it has like a max and a min, choose in the middle of that. And it just tries to do as much analysis as possible to get valid results from the form. Selects an option list, so drop-down list. What it does, it just highlights the element and then it just presses down twice and then selects that, which seems to be working pretty well. You could technically take every element in the drop-down list and say, okay, consider each one a unique new navigation and do it that way, but that's going to add a lot of potential paths that may not be worth it. For inputs that have a regex, there's actually a library where you can give it a regex and it will return you a string that will match that regex. So even if you don't know what it's supposed to be taking, if it has a regex bound to that input type, you can actually generate a string that will pass that regex check. So that's included as well. For things like type equals text where you don't really know what it is, I created this kind of form filling logic that takes out all the form's children, extracts all the labels, input attributes, placeholders, pretty much anything that I can use to deduce what it is. And then I take Chrome's auto form filling logic. So they have a series of regular expressions for all these different types, and I'll show it in the code in a bit. But then I run my input against that and say, okay, if it has like an attribute of like phone number and then a placeholder of like 011, maybe that's a phone number, and then pass it to the regex. It says, yep, this matched this regular expression. Okay, it's a phone number. Use the default for phone numbers. So what's interesting is it's worked so well that I don't have authentication built into my system yet, but if I have my username and password form filled to the correct values, it will actually go through and log into JuShop, WebGoat, and DVWA. So it's working pretty well so far. So now on to attacking. As I mentioned, passive plugins can register for what they want, but they're technically always on. They're passed through a dispatcher service. So this dispatcher service will basically filter stuff out and say, okay, is this a new event, or is this something that I've seen like 10 times? And then it'll only, depending on what the plugin's configured to receive, it will dispatch to it. And again, I'll show that in the code as well. But it just allows you to not have to call these plugins every single time with every single event. This dispatcher service kind of is a gatekeeper to filter stuff out. Active plugins, they're definitely still a work in progress. I have it attacking URL queries at the moment. I just finished parsing JSON in my custom kind of injection AST. Body is also done. It isn't wired up yet, but I'm rewriting the URL one because I don't like the parser that I wrote. But that's for later. So the way that requests are parsed is I created this abstract syntax tree for injection points. And so if you have like a URL, it has paths and files and queries, it'll actually treat this as like an AST, and I'll tag their location inside of the AST node, saying, okay, this is a path node, this is a file node, this is a query name node, this is a query value node, this is a JSON node, etc. What that allows you to do, since you're treating it as an AST, is if you have, let's say, JSON inside of XML, you could technically take an XML node, look at its value and say, okay, this looks like JSON, pass it to the JSON parser. It'll parse out the JSON parsed version, create the AST for that in JSON, tag it, insert it into the tree. And then as you're going through your injection points, you can actually say, you can attack those individually, kind of outside of, like, you're not just replacing the entire XML value with some attack string, you're actually looking inside and saying, oh, this is a JSON value, I'm gonna put a JSON in there. And that also allows you to reserialize. So as you create this tree, once you have your attack injected, it may need to be encoded in a very particular way, especially for JSON or XML. So by having it tagged with its location type, I can re-encode it properly so that I know that it's going to go through. Yeah, so once the crawl phase is complete, it queries the crawl graph again. So it kind of creates a new process and says, okay, now that I've crawled everything, I want everything that's been visited, and I'm going to set it to an audited state. So if I audit it properly, set it to an audited state, that way I won't re-attack it. So it re-executes all those navigation paths, stopping before the final navigation. And then it takes all the requests from that original crawl phase and iterates over them. It parses all of those requests into its injection expressions, into that AST structure I mentioned. And then it iterates over all the expressions. And again, a plugin can say, I only want to attack query values, and it'll only send it those query values. And then the plugin modifies the value, sends requests, gets a response, and then hopefully finds bugs. I do want to elaborate a bit on sending requests and getting response, because it's actually extremely hard to do that from DevTools, because you have to keep in mind everything is asynchronous. So getting the response back to a plugin is actually quite a bit of a challenge. So the way that I solve this is the plugin is given the injector service, which gives it the current request and the injection expression. And then it basically says inject here. And that kicks off a something within the injector service saying, okay, generate a new unique URL, like just /attack some unique ID, create a closure of an injection with a Go channel. The Go channel basically waits for a response to come in. And that injection also has the request data and the unique ID to match on. So once the browser kicks off the request to attack, it can actually capture it and say, okay, here, replace that attack unique ID URL with this data that I have from the plugin. And this closure kind of waits for this unique ID to come in, and it has then something called the frame ID and network ID, which are two unique values that come from the browser's network process, which I can then kind of register and say, okay, if you see this frame ID and this network ID connected, register with this response channel. Then when the response comes back, it can go to the response plugin service and say, hey, does anything match this frame ID and network ID? Yes. Oh, here's the response channel for it. Put in the response, and that'll send it back to the plugin. The injection itself creates an isolated VM environment inside of the browser, but it's still within the context of the page you're on, which is good because then you get all the cookies and all the other good stuff. You don't have to worry about any of that replacing cookies. This isolated VM environment sends that kind of fetch attack unique ID, which is then captured, and then the request hooks come in, and then the response comes in, and then hopefully again the plugin gets the response. And it seems to be working pretty well so far. So, okay, sorry, I've been going really fast. Any questions?
Yeah.
Yeah.
So I should actually mention that yesterday we had a support request from a customer who cares a lot about security, and the browser, when you hit their login page, the browser returns a 302. When you hit it from our DAS, well, essentially from a command line tool, it returns a 401. So I I completely agree that I think the future of DAST scanning is in a browser.
Yep.
Although there are advantages to a proxy, like for example, some people run Zap using from their tests, and then they set up Zap as the proxy.
Yep.
So yeah.
Yeah, so that's definitely a kind of limitation of this system, but it depends exactly what you're testing. So if you're running your unit tests or your integration tests or whatever, and it's just calling a backend API, it's like, well, then you can have an API scanner do that. Like you don't need to have, you could still have a proxy-based system you'd need a proxy-based system to intercept that. Or you could give a API-aware tool your schema, and then it could test everything for you. You wouldn't have to worry about doing some sort of tests. You just have it generate the test based off of the either the Open API spec or the GraphQL format, which is something I'm working on. So hopefully that'll that'll be a thing soon too.
I more mean for tests that run a browser, but yeah, I see your point.
Yeah. So that's kind of interesting because I was thinking about that as well. And since I am running in a browser as well, I could technically consider this Browserker to turn into a proxy mode where it doesn't actively crawl, but it records what actions are being taken. So that is also a possibility where you would, instead of calling your, I don't know what the developers are using these days, but it used to be like Phantom JS. If you're calling with your unit test to start up a browser, you could actually replace it with this one that would be listening for the tests to start up, and then it could record all this information as well. And then as the test went through its actions or whatever, it would then be able to replay those actions in its attack phase. So I think it could still potentially work. It might be kind of a mess because you have to kind of replace the unit test browser with this kind of custom instrumented browser. But I mean, I don't see it being a deal breaker kind of deal. But I don't know. That's just a guess. It could go completely wrong. But
no, fair play. I think too, like I should say that I think this is brilliant, and I think we should investigate, particularly initially, opportunities for replacing the Ajax spider in Zap with what you've done. But one of the questions I have is about, so you talked about, a URL doesn't really mean much anything anymore. But it's kind of like some of the challenges I feel like we've come up against in Dast is, what is a page? Because Dast makes an assumption about what a page is, but realistically, every application defines it themselves.
Absolutely. And that's the crux of Dast is that there's just so many different ways of doing things. And so it's funny, in some instances, URLs are meaningless. And in other instances, they're very, very important. Like you need to know exactly what URL you're attacking. So you, for example, don't attack the same thing over and over again. What I meant by that earlier is that in the context of crawling, URLs are meaningless. Like you don't want to be just like extracting links and then loading those links individually. You want to be following a process to get it to get more coverage. But you still need to capture the URLs because that is very much used as a uniqueness kind of for context for doing other types of things within Dast. So, but yeah, I agree. It's hard because everybody does everything differently. Which is actually one thing that I have on my roadmap is uniqueness, better uniqueness checking for pages. So at kind of like at a higher level, like for example, if this tool right now hits a calendar, it's probably going to go through all of the months and days and click on everything. It has limits. You can set a max depth of how far it's going to crawl, but breadth-wise, it would still need some sort of limit. And even if you set like a limit of, I only want to do 5,000 actions, it could end up going down that calendar for 4,000 of them. So you want some sort of system to say, okay, I keep hitting these pages over and over again. These are almost always the same. Kill it at this point, and then don't traverse the rest of those links that were generated from it. So yeah.
Yeah, or even if it could using, like, it could in theory work out that there are path parameters because the URL is only changing in one slight spot and that the page is mostly the same. Like in theory, if it worked out that the structure was the same, it knows it's already scanned it.
Yep, exactly. And those things aren't in there yet. They definitely need to be because there are going to be cases like that. But yeah, there's a couple different techniques you can use to kind of limit the possibility of that happening. All right, we are on to demo. So the way Browserker works is it actually kills all my browsers. So we're just gonna, this is
I
gonna
have a
disappear.
question for you, Zach, before
Yes.
going
Yeah.
to the demo. Yeah, you mentioned about filling forms that it could end up with a dead end. Like, I don't know, you're filling out a phone number and the phone number is not in the right area. You will have
Yep.
an error in the form. How easy is that to spot in the crawl graph in the end?
So it's not, it's easy. Obviously the crawl graph, you will be able to see where it stopped. You won't know why it stopped there. Looking at the logs, you will be able to determine because it'll say, hey, I can't find any elements here, or I'll show the logs in a second in the demo.
Okay.
But yeah, there's still cases where the crawler is not going to be able to do certain actions or something changes, like it's a timing based issue. Maybe it fails to load JavaScript. But there's a billion different reasons that it could not be able to properly fill a form, including having invalid inputs that just don't match what the form
of
expects.
course I understand that, but I'm thinking, for example, of the case of GitLab. We have thousands of different pages, URLs that are going to be crawled, and we might need a way to figure out that there was a dead end at some point, that the crawler was not able to fill a form correctly, and actually we're not seeing everything that is after that. We had a security issue lately with one of the features that we developed in Defend, and that was something in the form. And I'm not sure that if we get this huge form that you shared in the README, we would be able to spot that actually we were not crawling the right thing. So that's not asking for an answer right there, but I'm just
but I get your point. I totally get your point. Yeah, that's going to be difficult because you're at a point where you're scanning the unknown, and without a baseline of knowing what it should be finding, it's not going to be able to know.
Exactly.
I mean, you could mark certain edges as having issues versus not finding anything. So you could create this crawl graph and say, okay, anything that's colored red, there was an error, which means it wasn't able to continue on, or it was green or I don't know, yellow or something, where it didn't detect anything that it could continue on. So there's techniques you could use, but
would be great. Fair enough. Thank you.
I feel like there's a potential though like if we did integrate with engineers' tests and the tests were okay, you would understand some level of how big the surface area is from the tests and how much of that surface area you're actually testing with Dast. And while a lot of Dast tools that fill out forms do their best to fill out the correct type of data with a form, there's absolutely no guarantee that it's going to pass conceptual validation by the application. And I feel like you could potentially learn a lot from what people run in their tests about that as well. But obviously, pie in the sky.
Yeah. Future features. Okay, so let's go to here. So this is just going to kick off a crawl against DVWA just because it's fast. It's like 3 minutes. This is what the configuration looks like. It's just a TOML file. You can set up your URL, your allowed hosts, your excluded URIs, your path, your data, disable headless sysful. If you turn this on, it'll start opening up browsers and you can actually see it crawling and seeing what it's doing. But it's really annoying because you can't click on anything. So I'm going to keep it defaults for now. I'll show it in a second though. You can set the number of browsers. Certain applications will have issues with large number of browsers because it's basically crawling it with that many browsers. Max depth sets how many actions it can take. Right now I just have to set to 25. It's not going to reach that limit, but something more legitimate would probably be like 10. And I'll show what that actually means in a second. Your JavaScript plugins, and then your form data. And this form data can be, you can override what's in the default. So here's kind of the form data itself. You can have usernames like name related, address related, credit cards, and you could add to this if you wanted to. And then it has kind of like defaults for each one of these. So it'll suggest these values, and anything that you define in your configuration will override that. So we're going to run it with the DVWA config. We're going to output a dot file, and we're going to profile it. And it should work. So that's going to kick that off. This is DVWA for those who are not aware. It's a pretty simple application. We're going to look at. So if no one has seen this before, the tooling in Go for their profiling is absolutely amazing. You can look at all the Go routines. Maximize this, so you can see exactly what the scanner is doing. You know, everything that it's waiting for, how long it's waiting. You can look at allocations. It's just like, I love this tool. Like, it's just really, really good. So definitely keep that in mind if you have to do debugging of long-running Go processes. So while that's running, let's see if I have, yeah, I can just tell the debug log. So this is it kind of going through, and you'll notice that the each kind of event that's happening has the browser ID and then the action that it's taking, the actual navigation path, and then the step that it's on. So this helps you when you're debugging to say, okay, I'm on step 2. I wasn't able to query select all for some node type 58. And then you can kind of go back and use that to help yourself determine what it's failing, or what issue it's having, or maybe why it is or is not finding something. And then it just kind of goes through that, and you can see it'll continue crawling through all this stuff and then clicking. And each one of these, it's also nice about having the unique browser IDs is a lot of the times it's going to be doing very similar actions, and it's really hard to filter out which browser was having the issue. So again, being able to key off the browser IDs and the navigation it's taking is like super key for debugging issues. So here's the kind of main package I was talking about earlier. It's basically, these are your base domain types. So like action types, this is the types of things that the navigation can do, whether it's left clicking, executing, loading, and then all of this stuff is in there. Authentication service, not implemented yet. Browser service, this is just the interface of what it can do. And again, all plugins get this kind of interface that they can work with. Configuration, kind of already discussed, but there's other things like the form data, so you can config, oh, excuse me, was it? No, I guess it's pretty much everything. Oh yeah, authentication stuff, again, not in there yet, but it'll be available for developers and users to use. Context is very important in terms of Browserker, where all of these browsers are given a context, and that context in, oh, it already finished. Actually, yeah, let's look at the findings. So it already finished. That was pretty quick. If we just format this properly. So you can see that it found local file inclusion on, there's the evidence, when it was found. I don't have any of the other stuff on there, the targets. I don't, again, it's missing a lot of stuff because it's still kind of newish. And then headers, again, it only ran once for the entire page or the entire site. So it only reported it once. So it appears to be working, which is good. And then the graph itself, review this. So here's the crawl graph. So you can see that it loads the URL, fills forms, and then it kind of gets a number of actions. This is, if you imagine looking at the application, that would be this part over here. So you can see it's just like clicking on all these things, which then leads it to either click on more stuff or fill forms. And then it has a final like end node of this container ID. I don't know why, but that seems to be where it stops. So yeah, it just helps figure out like, okay, so it went from here, then it went to there, and then went to there, and that's why it did that. The benefit of having this kind of crawl graph is if you notice something that it's getting stuck on, or you expect it to find a certain thing, is you can use the replay tool. So we're going to pass it the config array. We're going to do something called list. So this will list all the navigations that it took with an ID. So let's say it gets stuck on, I don't know, so it gets stuck here. So this ID it gets stuck on, and you want to know why it's not doing anything after this left click. So you can actually replay with a nav ID. And what it's going to do is open the browser for you, and then you can watch it kind of go through clicking on stuff, and then you can figure out, okay, this is why. And you can look at the logs too. It has all the logs just as if it was running. So you'd be able to help. You could either turn on more debug logs to figure out what it was doing, but it should be pretty explanatory from what's there. So that's that. Any questions so far?
That's really cool.
Yeah, I did this like last week, and I'm like, why didn't I do this from the beginning? Because I was having troubles of getting it to crawl, I think, WebGo, and I couldn't figure out why. And I was spending so much time just rerunning scans that I could just like, why don't I just replay it? It's like, that makes way more sense. So then I could figure it out. Yeah, I'll just do a little bit quick walk through the code because I really want to show like the form filler and stuff. For those who do Go at GitLab will be familiar with the UR fave stuff. It's all built using that stuff just because I actually end up liking it. So it's got a couple of tools kind of built in, the replayer, the crawler, etc. Configurations I have kind of set for each one that I've tested so far. Yeah, so use those for examples. So the scanner package is kind of like the heart of everything, where it has the browser. As I mentioned before, the browser has the kind of the leaser service. And this is how it kind of starts up Chrome, so you can disable various things. It tries to minimize any sort of like updating stuff and requests. It doesn't matter. And I've kind of like curated these over the years because they keep changing and new ones are added, which really help. But yeah, so the browser pool does the actual like taking up the browsers, and then the browser tab is basically where I am tracking everything within as it's being instrumented. So yeah, lots of code here for clicking on stuff like sending. This is this select field, like it just says, hey, send down arrow, and then press enter, and that's how it does it. So if you want to figure out how form filling works, it's the place to look. Some interesting actions is probably in the crawler. So the form handler, so when a new navigation is found, it passes all the details to this form filler, and then it fills out what it thinks the suggested values are, and it passes that back to the engine. The engine then stores that information in the crawl graph, so it's there and you can review it if you needed to. But here's the kind of the suggested input kind of field. So it says, okay, if it's a checkbox or if it's a color, return this color. If it's a date and there's no minimum set, then just return it's kind of a default date. And then same for like, yeah, various input fields. Like if it's an email, like, okay, we have form data email, just use that. And then for months, etc. Again, it tries to find valid ranges in between those passwords, pretty much everything. And then there's this suggested text input. So if it's like a text field and you don't know what it is, it takes the label information, placeholders, names, IDs, and then it runs it against all of these in a very particular kind of order of operations of what it expects to be kind of first. So like searching is usually a pretty obvious thing that it's going to do. And all of these regular expressions are taken from Chrome. I just had to modify them because they use a different regex library, but yeah, these are how it matches. So when you're doing your Chrome form filling stuff and it automatically suggests an input, it's using these. This is how it does it. So I just kind of hijacked that for my own purposes. So, and then for the injection stuff, again, it has its own like AST. So you can see it's got kind of default nodes like an identifier, index expressions, key value expressions, object expressions. And it has these kind of methods for modifying them or returning them as strings. So if they're modified, basically replace what the original value was with your modified value, and you can reset that so it's easy to reset as you're iterating over them. And then we have URI parser, or sorry, is it? Oh, this is the old one, but parsers itself, each thing you want to support will be its own kind of parser, and then you parse it into the AST format. So again, I'm using, in this case, I've used Go's built-in decoder object to kind of use it in my format. So it worked out really well. So other things to look at, plugins. I want to look at a plugin. So here's a kind of base plugin. They all fit this interface. You have a name, ID, configuration, and then your options. So this is how you register. You say, okay, I want to write requests. I want to always execute, but I only want to execute inside of injection values. And you can actually choose, these are the different paths you could inject into. And then there's kind of like set ones of like, okay, I only want to inject into values. So just take the set of query values, header values, JSON values, etc. So it makes it easier to only listen for certain things. What was that? So then we have the injection. So this is when it's actually injecting. It calls this ready field and it says, okay, I'm going to attack with these attack strings. And this is what it actually used to find that flaw in DVWA. And it looks pretty easy from the plugin's point of view. It just says, okay, inject here, send the request, and then get the response, and then check if it matches what you expect it to match, and then report. So pretty straightforward for that stuff. Kind of running low on time here, and I want to talk about roadmap and next steps. So the scanner itself, this is the main process where it sets up the context first. So it's going to have its scope context, form handlers, and all that stuff that's shared amongst all of them. And this context object is basically copied to each one, to each browser. And then the browser itself basically takes that copy. Where is it? Yeah, it takes that copy and then it allows it to inject its own kind of handlers. If it wants to inject JavaScript, that'll be isolated to just that navigation, and they can redo it that way. Yeah, there's a lot of stuff here that I just don't have time to go through. But if anybody wants to do a code walkthrough with me, let me know. I'd be more than happy to do it. So, any questions on the demo so far? Yeah. All right. We will get back to the slides, which it killed all my browsers. So. Ah, you gotta be kidding me. Oh man, terrible timing. Yeah, that's annoying. Well, I don't feel like logging in right now. So yeah, no, I guess I have to. Shoot. All right. I'm gonna shut off sharing screen real quick. Why don't we have a discussion?
Don't worry.
Yeah, just in case.
You're still sharing. Okay.
Yep. Give me one moment.
This is a mammoth task you're undertaking. You know that, right?
Oh yeah, I absolutely know that. Because there's like, yeah, if you go through my code, like, to do here, to do here, to do here. Like, there's just so many different things that you have to be aware of it. And when you start getting into crawling different apps, it's just like everything's an edge case. So it's always fun to deal with. But
So
I mean, yeah, go ahead.
I saw for authentication, like you have basic username, password, form filling, and stuff like that. What additional things are you adding for that to fully support auth?
Yeah, that's a great question. So there's certain things that would need to be done to like OAuth and stuff, like being able to go outside of, because right now the way my scope check works is I inspect the request. I say, is this trying to load a document? Yes. Is it outside of my allowed list? Yes or no. If no, then it basically aborts the request. So there's certain things that I have to do there. Also, I'm still kind of undecided if I want to have it re-authenticate every single navigation path. It may make more sense to have a centralized authentication path that it can determine if it's being logged out or not, and then only re-execute the authentication, because that does take time. Those are requests that are being executed every single path. So kind of like, it's more like an optimization at this point. So almost back here. Okay. You gotta be kidding me. Did not log me in. One second. All right, back to slides. Good. Now I can share my screen. Okay. So roadmap it's basically taken from my page. A lot of the parsing stuff I'm still working on, but hopefully I'll have that done pretty soon. Yeah, actually I already did that. Just a lot of it's mainly around getting like timing attacks working and like various cross-site scripting stuff working, handling failures and stuff. And this is kind of in order of importance and what I think I'm going to get done. So anybody wants to look at that, it's there. Future ideas. Since the scan is stored in a graph, I've figured for doing replaying like incremental scans, it should be pretty straightforward where you would already have the graph set. You would recrawl that graph, and then anything that's new, you would only attack that. So then you could say, okay, I found 6 new navigations compared to last time, rerun, but only attack those 6 navigations that were considered new. So I figured that should be relatively straightforward. Supporting more data formats, GraphQL, obviously I'd like to get done. I'm actually doing a GraphQL scanner for GitLab on my actual paid time. So something, possible integrations with that. Selenium parsing, allowing user to provide authentication stuff. And then obviously I'm open to suggestions and ideas. But yeah, that's my roadmap. Next steps. So yeah, this is basically just a side project for me, but I've reused a lot of code from my kind of previous dealings with browsers. It's very much still a whack-a-mole process with it in terms of crawling. I've only done 3 or 4 applications now. I'd like to get more tests just to make sure that I'm getting good coverage. And it's really annoying because when you're doing crawling, like something that may work really well for one app, you end up changing it to make it work for that app, and then you try to rescan your old apps, and then all of a sudden they don't work anymore. So it's definitely this like, you have to balance these changes with your crawler quite significantly. Yeah, so I've just tried to build this as like each small component just to make sure that there's no crazy issues that would stop me from this project actually working. I almost had one, which was like some networking issue that I forgot to update my code. And yeah, open to contributions. And if I tweet about this a lot, so if you want to follow along, pretty much every night I do about an hour just to mess around with various stuff. But yeah, that's pretty much that. Looks like we're right on time. Any questions?
Yeah, I do have a few, but we're right on at the end of time here, so I can ping you about some of it. But I guess one of my main questions right now is based on the I don't know, GitLab maturity levels. I would actually put this above a minimal maturity, maybe even around viable. How close do you think that it would be to actually integrating it to DAS to where we could use it for some, like starting to test with it and see how well it works inside a DAS scan?
Yeah, so it would need more plugins. Obviously, I only got like 2. I'm only looking
Right.
for headers and cookies, but I mean those are pretty straightforward. Again, it's more of like the attacking different aspects. Right now, it's only attacking queries, so it need to support the body and stuff like that. But again, hopefully, I'll have that in a couple weeks or so, 2 weeks. But given that, what would be interesting is to have I don't know if this is possible with GitLab's architecture, but something that I've done in the past is to have a shadow scan. So what you do is you have your customer request a DAS scan to kick off. We also kick off another one that's not really visible to the customer that we're then able to review the results for. Again, given GitLab's history with the metrics and telemetry, there may be issues with that, but maybe it's an opt-in feature that you're like, maybe you want to try out DAS 2.0 or something. So that's definitely a possibility, but I think again, there's still very much whack-a-mole with crawling different applications. It would be great to have more data, but I don't know. It really depends on what customers would be comfortable with.
Yeah, absolutely.
I think for me, that's where like the Ajax spider in Dast, the Dast solution right now is almost external to Zap because like you said, it's not first class. So if your solution had a really good Ajax spider, particularly for SPAs, which is what Zap is, one of the things that Zap is terrible at, then that would be very easy for us to interject your application in there and then gradually build out like replace parts of Zap with, you know, solutions built by
Yeah,
browser.
yeah, I thought about that as well, where we could actually potentially just take the crawler aspect of this and then wrap it in a Zap extension and then see if it does any better. I don't know. Yeah, no. Yeah, I mean, since since Zap is going to proxy all the data anyways, I don't really see an issue with that. I'm just worried about like maybe some sort of networking issues between the two, but I mean, it'd definitely be worth exploring.
Yeah, and to build off of that, I mean, Cameron, I think that you're right. We could, as the plugins are built, you know, we can introduce those and start to turn those on to get more coverage, and still use Zap for kind of a main scan, but then start to turn things on as we get it within what you're doing here. I mean, I think that could be a way forward so that we continue to support what we have, but then also start to introduce better functionality.
Yeah, yeah, especially in terms of like having to, for all the configuration work that's been going into DAS right now, it would make sense to have that stay the same and then kind of use this as a crutch for crawling.
Yeah.
Yeah, that's kind of how I had envisioned it as well, as a supplement until it can be a replacement.
Agreed. Great. Well, that's pretty much everything for what I have. I'm gonna stop sharing.
All right, I'm gonna go ahead and stop the recording now.